Hello class, today I want to continue with the idea of triangle similarity, but today we're dealing only with right triangles. And as you might guess, it does work differently than the other triangles. The other triangles we dealt with by proving through side-side-side similarity, side-angle-side similarity, or angle-angle similarity. Now, when you take a right triangle, like in example 1 of your notes, and you drop what's called an altitude. In fact, go ahead and write A for altitude. It comes at that vertex down at a right angle. It has split this larger right triangle into 3. You've got the big one, and you've got the little one, and you've got the medium-sized one. Now, there are parts of these right triangles that you're going to have to commit to memory, and I'm going to label them for you. This side we're going to call leg 1, and that side leg 2. And I'm talking of the bigger triangle. That's the altitude. This part of the hypotenuse is segment 1. That part is segment 2. Now, all that matters is that if this is leg 2, that you have segment 2 here. You could have made it over here. That would be fine, but the two have to go together. And then the hypotenuse is this whole leg. Now, there's 2 little formulas. One is called the altitude formula. One is called the leg formula. And I'm going to write them here, and I'd ask you to write these down on your notes. The altitude formula goes this way, that the segment 1 compared to the altitude is the same proportion as the altitude compared to segment 2. So in other words, this altitude compared to that is going to be the same as this compared to that. Now the leg formula works this way. The hypotenuse compared to the leg, and I'm dealing with leg 1 right here, will be the same proportion as that leg to its segment. That's why you got to keep these segments together. Or if you're looking for the other leg, it's the hypotenuse to leg 2 is the same as the leg 2 to segment 2. So, in this particular one, number 1, we're looking to find leg 1. So I'm going to use this formula. The hypotenuse is 36 plus 64, so that's 100. I hope you didn't miss that. Again, let me go over that one more time. I want the hypotenuse length, and that's from here to here. That's this piece 64 plus 36. So I'm going to say the hypotenuse compared to leg 1, that's the x, is the same as leg 1 compared to its segment, 36. Now at this point we're going to cross multiply. Leg 1 times leg 1 is leg 1 squared. 100 times 36 is 3600. Now what are we going to do to solve for leg 1? Well, I hope you can see that at this point we're going to take the square root of both sides. The square root of leg 1 squared is just leg 1. The square root of 3600 is 60. And so that's the answer. That's the length of that side, is 60. All right, in number 2, what are we looking for? Well, we're looking for the altitude. So, as you might guess, we're going to use the altitude formula. Well, that's up here. In this case, it doesn't matter whether you call that segment 1 or segment 2, but it's the only one we've got. So if this piece is 16 and the hypotenuse is 25, then segment 2 has to be 9 units long. So let's plug it into the altitude formula. Segment 1, 16, compared to the altitude is the same as the altitude will be compared to the other segment 9. And you cross multiply, you get a squared is equal to 144. And since that's a perfect square, that's easy enough. We take the square root of both sides, and that altitude was 10 units long. And so that's examples 1 and 2. All right, let's go on to examples 3 and 4. Now you have to decide what is it you're looking for. Well, I'm looking for a leg, so let's call that leg 1, call that segment. Oops, not segment 2, so call that segment 1. The two need to go together. So let's go for it. The hypotenuse formula is, the leg formula has the hypotenuse. In fact, let me write it down one more time. So the hypotenuse is 25 compared to leg 1 will be the same proportion as leg 1 compared to its segment of 9. Cross multiplying, we get leg 1 squared. 25 times 9 turns out to be 225. And you take the square root of both sides, and leg 1 is 15. All right, number 4. What are we looking for? Well, we're looking for the altitude. So we're going to use the altitude formula, which says, and we can call this segment 1, segment 2, that segment 1, 64, compared to the altitude, will be the same proportion as the altitude to the other segment. Cross multiply, we get that the altitude squared is equal to 2304. And now we're going to take the square root of both sides. And when you do, you'll get that the altitude is 48 units. And that's 3 and 4. All right, now these next few are more difficult, but it's the same two formulas. You just have to figure out what information you're given, what are you missing. Now, in number 5, we're looking for, I don't know, let's call that segment 1. Well, we don't have a segment formula. We've got a leg formula and an altitude formula. So we have an altitude, so why don't we go with that one? Remember, the altitude formula is that segment 1 compared to the altitude is the same as the altitude to the other segment. Well, that's nice because we can say x compared to 12 is going to be the same as 12 compared to the other segment, 9. Oh, so 9x is equal to 144. Divide both sides by 9, and x is 16. So that wasn't too hard after all, though at first it looked like, how are we going to do this? All right, number 6. I'm trying to find the hypotenuse, x. I don't have a hypotenuse formula, but I do have a leg and a segment, and I can remember that the leg formula uses the hypotenuse. Remember, the hypotenuse to the leg is the same as leg compared to its segment. Okay, so we can go for it. The hypotenuse is x, leg 1 is 15, and that'll be the same as 15 compared to its corresponding segment, 9. Cross multiply, we get 9x is equal to 225. Divide both sides by 9, and x is 25. And there you have numbers 5 and 6. All right, here we go, the last two, 7 and 8. Well, here I'm looking for the hypotenuse. I'm given, though, an altitude, so that makes me a little bit suspicious. So let's go with the formula that uses the altitude, and that's that this segment, 36, compared to the altitude, will be the same as the altitude compared to the other segment. All right, that's this piece right here. Well, we don't have a number for that, but since the whole thing is x, and the hypotenuse is x, that piece is 36, we could call this x minus 36. And sure enough, that's what we're going to do. We cross multiply, and let's see, we get 48 squared here is equal to 36 times x minus 36. This becomes 2304 is 36x minus 1296. You add 1296 to both sides, you get 3600 is equal to 36x. And divide by 36, x is equal to 100. Now, I will admit, that one would not immediately come to most students, but just give that a little bit of thought. All right, similarly, with number 8, we're given a leg and a segment. We need to find that segment there. So let's go with the leg formula. Well, the leg formula requires us to have a hypotenuse. Well, if that's x and that's 36, how about we say that the hypotenuse is x plus 36? And let's plug it in. So we got x plus 36 over the leg 60 will be the same proportion as the leg 60 to its segment, 36. And you cross multiply, use the distributive property, and I'm just going to go ahead and give you the answer. It turns out that x happens to be 64. And that's similarity with right triangles.